Good morning. You are welcome to today's class where we'll be discussing the arithmetic progression under the main topic sequence and series. Alright, so in this content, we'll be discussing sequence. We'll be defining what we call AP itself, which is the arithmetic progression. We'll also explain how we derive the formula of the AP, the end term of the AP, and later we'll discuss the sum of AP. Alright, so we understand that we have numbers, and numbers can be arranged in either ascending order or descending order. Now, the order with which we arrange does not matter in this context. Okay, so and we can have numbers arranged in a particular order, following a particular law. So the AP comes in place when we need to explain this. For instance, if you look at the numbers arranged in A, these numbers here in A, you have 1, 5, 9, 13, 17, 21, 25. And if you are asked to state the next number, what will you do? You say, okay, how do we get these numbers? How do we get this sequence? Do you understand? Now, so for instance, to get 5, what did we do to 1? We added 4 to 1. So 1 plus 4 gives 5. 5 plus 4 gives 9. 9 plus 4 gives 13, etc. So if you ask to get the next number, what will you do? I mean the number after 25. You say 25 plus 4 gives what? 29. Do you understand? For instance, in this sequence, 2 will not fit in because it will not fall in. Do you understand? And let's look at B. We said 2, 6, 18, 54, 162, 486. What did we do? We did what? We said the term, any term multiplied by 3 gives the next term. Very simple. For instance, 2 times 3 gives 6. 6 times 3, 18. 18 times 3, 54, etc. Can you see that? Now for C, what did we do? We have 1, 9, 25, 49. Can you see that? So what did we do? We squared the odd numbers. 1 square, 1. Can you see that? 3 square, 9. 5 square, 25. 7 square, 49, etc. Can you see that? Now for D, what we have 10, 9, etc. So you can point out the law with which the sequence is generated. Alright, so I said in each case of the example below, or let me say above, there is a rule which will give more terms in the list. A list like this is called a sequence in many cases. It can simply matter if a general term can be found for a sequence. Do you understand? Alright, so look at this. For instance, if you have 1, 5, 9, 13, 17, it can be expressed as 4n minus 3. Now look at this sequence has a general formula that is 4n minus 3, where n is what? Number of terms. Let's check. The first term is 1. Let's slot 1 for n. 4 times 1, 4 minus 3 will give what? 1. Can you see this? Second term is 5. So let's slot 5 for n here. So if you have 4 times 5, that gives 20. Then minus what? Minus 3. Can you see that? So we get that as what? We get that as 17. That gives the fifth term. So to get the third term, you slot n to be what? 3 to get 9. Let's check if that's correct. 4 times 3, 12. 12 minus 3, 9. So to get each term, slot the value of n, where n is 1, 2, 3, 4, 5, depending on what the term you want to get. Alright, so example 2 says that find the 6th and 9th terms of the sequence whose nth term is A, this 2n plus 1, and B, 3 minus 5n. Okay, how do we get the term of the sequence given the nth term? We will only to slot 1, 2, 3, 4, 5, 6 as numbers inside the given formula to get the term we require of. For instance, if you are asked to get the 5th term, what will you do? Slot n to be what? 5. Can you see that? So you are asked to get the 6th term. So what will you do? You slot n to be what? 6. Now to get the 9th term, slot n to be what? 9 in A. So for A, slot n to be 6, we get 2 times 6, 12 plus 1. That's what? 13. So we get 13 as the term, as the 6th term for this nth term. The nth term gives a general formula for a sequence. It is the rule with which we generate the sequence. Now for B, we have 3 minus 5n. So to get the 6th term, we slot n to be 6. That gives us 3 minus 5 times 6. What's 5 times 6? 30. 3 minus 30 gives us minus 27. And also you can also slot 9 to get the ninth term. Very simple. If you give us minus 42. Alright, so you have this as evaluation 1 to 4. And also you have 5 to 7. You have to do all this. Alright, so let's quickly talk about AP itself, the arithmetic progression itself. Now, what do you mean by arithmetic progression? A sequence in which the terms either increase or decrease in equal steps is called an arithmetic progression. When we are actually adding something to to a to a number to get the next number, we call it arithmetic, meaning we are adding. Had it been we are multiplying or dividing, we call it geometric. Do you understand? So when we are adding or subtracting, we are doing what? We are adding. And that thing we are adding is a constant term called the common difference. Alright, so let's talk more about that. The sequence 9, 12, 15, 18, 21, etc. has a first term of 9. Now, the first term of any sequence is the one that I call first. 9 is the first term of this sequence. So, and we use A to denote the first term in arithmetic progression. A is the first term, where D is the common difference. So, and this term, of course, has a first term of 9 and the common difference of plus 3 between the terms. What do you mean common difference? The difference between between two consecutive numbers and AP is the common difference. For instance, the common difference in this sequence is either you say 12 minus 9, 3, or 15 minus 12, 3, 18 minus 15, 3, 21 minus 18, 3. Can you see that the common difference is constant? Hence the word common, because it's going to be common to all the times. If it is not common to all the times, then it is not an AP. It could be a sequence, but not an arithmetic sequence or progression. Alright, so we say A we denote the first term with A, common difference with D, number of terms with N, nth term with UN, or some will use TN, then sum of n terms with S subscript N, we call it SN. Okay, so let's get the formula for nth term of an AP. How do we derive the nth term of an AP? Taking this sequence as a case study, A is 9, we agree, and D is what? 12 minus 9, right? Or you say 18 minus 15 or 15 minus 12, we must get 3 in any case. So we say the first term, we use UN or TN to denote to denote the terms of an AP. So UN is the first, U1 is the first term, U2 second term, U3 third term, etc. But we also use A to represent the first term of an AP. Okay. Now if the first term is 9 of an AP, of this AP, sorry, and the second term is what? It should be 9 plus something, 9 plus 3. That gives what? That 3 is a common difference. So we say A plus D. Since that first term is A. Now to get the third term, 9 plus 3 plus 3. Can you see that? We are adding the common difference twice. So we say A plus 2D. To get the next term, we'll say what? A plus D plus D plus D as A plus 3D until we get to the 10th term. What is the 10th term? That's what? A plus 9D. What would you notice? We see that for 10th term we have 9D. For third term we have 2D. So it means the number here will decrease this one by 1. When we have second term we have 1D. Can you see that? Therefore, if you have nth term, to be what? A plus n minus 1. Since if you have 10, it will be A plus 10 minus 1D to give us 9. So if you have nth term, it will be A plus n minus 1D. And this is the general formula for your arithmetic progression. So if you ask that what is the general term or the general formula to get the nth term of an AP, just say A plus n minus 1D. Don't forget the n minus 1 is in the bracket multiplied by what? D, the common difference. Where n is the n, and where n is the number of term, A is common. A is the first term, and your D is the common difference. Alright, so let's take one example. Please master this formula. It is very, very important. Okay, for example 1 says, given the AP 9, 12, 15, 18 up, okay, we don't know the rest. Can you see that? Indefinite sequence. Okay, find the 50th term. Now, I know you, if they had said find the 1, 2, 3, 4, 5, the 5th term, it would have easy for you. What would you have done? You would have said, okay, 12 minus 9 will give me what? 3. Just add 3 to 18, and that gives us what? 21. But what if you are asked to find the 50th term? Will you keep adding? That will be strenuous and too tasking. So a fast method is using the formula that says un equals to a plus n minus 1d. So you just say, okay, u50, that's 50th term, is what? A. Your a in this case was 9 plus n minus 1. The 50th term, n is 50. So this n is the number of term. Had it been the third, you find the 40th term, n will be 48. So the 50th term, n is 50 minus 1, that gives 49 times 3. So you do bracket first, board mass. So 49 times 3 gives 147, then out of 9 we have 156. Very simple, right? Okay, so you have number 2 question that says the 43rd term of an AP is 26. Find the first term of the progression given that its common difference is half, and also find the 50th term. Okay, we know that it was the 42. So you guys always try to write out your given parameters. For the 43rd term is what? 26. We are given that what? The first term of the sequence. Okay, or the find a. So a is question mark. Can you see that? Also, we are given that the common difference is what? Half. So d is half. Now, having the parameters at hand, what do? You can make up an equation from this. We are given that, but we know that our general formula to get the n term is what? Un equals to a plus n minus 1d. So you have un to be what? 26 equals to a plus n. N is what? For the third term, for the 3 minus 1, d is what? Half. Now make that an equation. Get 26 equals to, if you say 42 times half, you get 21. Then make a this subject, which should be what? 26 minus 21. That gives what? A equals to what? 5. Now that we've got a to be 5, to be easy for us to get other things. Now we're also asked to find, to find the what? The 50th term. Very simple. What do? We know that what? Un is a plus n minus 1d. So just find u50. So u50 will be what? A plus 50 minus 1d. So our a is still 5. We have 5. 50th term. So 50 minus 1 times d, which is half. Okay, so know that we have what? 5 plus 49 times half. That gives us 24 and a half times 5. When you do n plus 5, when you add that together, you get 29.5 or 29 and a half. I believe that's clear. Alright, so in our next class, we'll be talking about the sum of an arithmetic series. I hope the class is clear. So you have this evaluation 1 and 2 and the first evaluation to do and submit before the day runs out. Thank you and have a nice time.